Financial Maths, Geometric Series, Type 2, Bonds. So in the previous example, we were looking at savings. And with the savings, we were looking for what would the sum of all of those lodgements amount to in the future. So we were getting the geometric sum of the future values of each of those lodgements. In this type, we're looking at bonds, and generally we're looking for the present value of the bond. So that means we're going to be working out the sum of the future payments in the present day. So you're kind of working backwards. You're going to be getting the sum of the present values. So in this particular example here, we have a company wishes to raise capital to expand their business. They offer a 10-year, €2,500 bond that will pay €100 every year at the end of each year for 10 years. And we're given an APR of 4.5%. And it says, well, calculate the fair market value for this bond. In other words, what would somebody pay for this bond today so that they receive €100 at the end of every year for 10 years? So our first step, as always, will be check, does our rate match our compounding periods? So in other words, does the rate match the compounding periods? In other words, is the rate yearly and is the compounding periods yearly, or is the rate yearly and the compounding periods is monthly or biannually or quarterly? And if it doesn't match, then we have to change the rate using our F equals P by 1 plus I to the power of T. So we can see in this question that it's AER, which is yearly, and yet we're paying out €100 every year for 10 years. So therefore we don't need to change our rate in this particular example. The second thing that we need to check then is, when are we paying out this money? So in this particular example, the bond is paying out €100 every year at the end of each year. So is it at the start or is it at the end of the compounding period? Now, this is going to be slightly different to our savings, because in the savings we were looking for what was it going to amount to in the future. So if it went in at the start, it earned interest for that whole month. If it went in at the end, it didn't earn any interest. So this is going to be different because we're discounting back our values to the present day. So if it's going in at the start of the compounding period time and you discount it back to the start, well, clearly there is no interest because you're not discounting it back. And that would be for the first €100. Whereas if it's going in at the end, then that means it is earning interest. And therefore you will discount it back. And that would be for the first one, because every other payout will obviously be discounted back by a certain amount of time. So therefore our first €100 that is paid out will have to be discounted back by 1 year. Now, because this is a bond and we're told the price of the bond, then what we need to do is work out the present value for the bond. So in other words, if we're getting our present value, that's going to be F divided by 1 plus I to the power of T. And then we also have to work out the sum of our present values of the payments. And we'll be using our geometric sum. and then you'll combine the two together. So you'd get your present value for the bond and the present value for all of the future payouts, and you'd combine the two together to get the fair market value. Okay, so what we want to do first of all then is we don't need to change our rate. We've checked our money and it's been paid out at the end of each year, which we know then that the first payout has to be discounted back by 1 year. So our step 3 then is to work out our present value for the bond. So our bond is worth 2,500. We know the interest rate is 4.5% per year. So therefore that's going to be 0.045. The time is 10 years. And we want to know what would that be worth now if they're getting the 2,500 after the 10 years. So P is equal to F over 1 plus I to the power of t. So that means it's 2,500 divided by 1 plus 0.045, which is 1.045, and that's to the power of 10, which gives us a present value of €1,609.82 today. So now we have our present value for the bond itself. We now need to work out the present value for all of the future payouts. So we have €100. So we would say P is equal to, well, the first €100 has to be discounted back 1 year because it went in at the end of the year. So as we said, it has to earn interest. So we're discounting back 1 year. So interest applies. Whereas if it went in at the start of the year, then that would be to the power of 0 because it wouldn't have earned interest. The second payout is €100, which means it would have to be discounted back 2 years. And so on, all the way till we get to our last payout, which has to be discounted back by 10 years. So this is the last one. Whereas with our savings, we wrote it in reverse. So in other words, we say it's the sum of the present values of the future payouts. So again, like in our savings, I'm going to take out 100 as being common. You don't have to, but I think it just kind of simplifies things a little bit. So we can see our geometric series clearly. So everything inside here is a geometric series because we have a first term and we have a common ratio. Where our first term is 1 over 1.045. Our common ratio, well, I'm multiplying everything there by itself, so my common ratio is 1 over 1.045. Or this time is less than 1, which means I'm going to use a times 1 minus or to the power of n over 1 minus or, as found in our maths tables, page 20. And how many terms do I have? Well, my compounding periods is 10. Which means that I must have 10 terms. So subbing my values in, that means the sum of the first 10 terms is going to be 1 over 1.045 times 1 minus 1 over 1.045 to the power of 10 all over 1 minus 1 over 1.045. So again, making sure you're subbing that into your calculators very carefully. So that gives us 7.912718177. And then, of course, I now have to find out the sum of those present values by multiplying by 100. Which gives me a present value of all of those future payments of €100 to amount to €791.27. So therefore we have the present value of the bond is €1,609.82. So that's the 2,500 discounted back 10 years, plus all of the €100 that are going to be paid out at the end of every year for 10 years, amounts to €791.27 at present. So therefore, by combining those two together, we say, therefore, a fair market value for the bond would be €1,609.82 plus €791.27, which gives us a fair market value to pay for the bond of €2,401.09. So in other words, what this means is that if an investor purchases this bond now at a fair market value of €2,401.09, then they will receive €100 at the end of each year for 10 years, as well as the payment of €2,500 at the end of the 10th year. Okay, so I'm just going to get you to do one question. So you're going to go to page 264 in your books. And I'm going to get you to do question 8. Now, question 8 doesn't tell you what the bond is. It's just telling you the payout. Where if you were to look at question 7, if you want to do an extra one, question 7 is pretty much similar to this example, where they tell you the price of the bond, which is 2,000, and they also tell you the payouts. So in 8, we don't need to get the present value of the bond because we don't know what the bond is, we just know what the payout is. So again, watch for timing and interest rates.